Hey everybody, this is Mrs. D. We're going to do some more exponent work here, and we're also going to look at some roots, square roots and cubed roots. So, the first problem here looks a little intimidating if I say do this without a calculator, because the temptation is just to enter it into the calculator. But what I suggest we do is work with this 6.25 number. I know 0.25, hopefully you do. If you don't know 0.25, maybe you know 0.5. Hopefully you know that's a half. And then 0.25, well that's just half of a half, and half of a half is a fourth, dividing it by 2. We could even go further with these decimals and say, well that's half of that, so that's an eighth. In which case something like this, ooh, what's that? 0.375, well that's 3 of those. That would be 3/8. So just some work with decimals, changing them into fractions. Now why am I telling you to do that? So this is 6 1/4. Because it's going to help us simplify this. If we simplify this by making it an improper fraction, we would have how many fourths? Well, 6/4 would be 25. And then there's an extra fourth. Sorry, 24. And then an extra one brings us to 25. I'm thinking ahead here. So we have 25 fourths. Oh my gosh, that would be so much nicer to take a square root of. Because we could do the square root of 25. And we could do the square root of 4 separately, leaving us with 5 halves, which is our answer. Very nice. Also known as 2.5. Now, this next problem here deals with simplifying a square root. So to simplify a square root, we need to try to break down this 98. And we've done that before in the quadratic formula. So what we look for, looking for perfect squares in 98, hopefully we know that 98 divided by 2 would be 49. So that does simplify quite nicely. We have a square root of 49, which we know is 7. And then the square root of 2, bummer, we don't know that. So we're going to leave that as the square root of 2. Now, looking at these variables, when you take the square root of x squared, that's not too bad, you just get x. But when you take the square root of y cubed, think about that y cubed as a y squared with a y. We can take the square root of y squared, that gives us y. Then there's still a y left in the square root, so we've got a y we could bring here. But then remember, these guys were still left as square roots. So they're going to remain in the square root, the 2 and the y. You can't really take the square root of those, so they remain as an irrational part of your answer. Now that works very, very similar to this third problem, except for this time we're looking for perfect cubes. Now maybe you don't know your perfect cubes, so you might want to make a list. 1 cubed is 1, 2 cubed is 8, 3 cubed, 3 times 3 is 9 times 3 is 27. 4 cubed would be 4 times 4, which is 16, times 4 again is 64. 5 cubed, another popular one, 5 times 5 is 25, times another 5, 125. Any of these numbers, if they are factors, and it does keep going, of course you know that, but 64, yippee skippy, it is a perfect cube. So what is the cubed root of 64? You could almost imagine breaking this down, taking the root of each of these. So we get cubed root of 64, we just said was 4. The cubed root of x to the 5th is a little tough to do, but you could say it's x cubed times x squared, and the cubed root of x cubed is x. But we still have that x squared left in our root. Now the cubed root of y to the 9th, you could think about that as y cubed, and another y cubed. Oh wow. Cubed root of each of those would be a y, so we've got a y cubed there in fact. And the x squared remains in the cubed root. Now, if that's a little hard for you to follow, maybe you want to think about these as fractional exponents. Oh man, not me, I don't like fractions. Well, look at this one. This one would be a lot easier if you looked at it as a fraction. We have y to the 9th, and then the cubed root would mean we have a third in our power. Well, what's 9 divided by 3? 3. How about this one? X to the 5/3. Well, that's 1 whole with 2/3 left over. So there's your 1 whole and the 2/3 left over.